Welcome to Wales Tech Week 2021. Thank you to our partners. Enjoy the session.
Welcome everyone. Thank you for joining us on the very first day of Wales Tech Week for our session, Photonics in Action, how to keep growing and innovating. So my name is Hazel Hung and I'm the Business Development Manager for CPE, the Centre for Photonics Expertise. I'm delighted today to be joined by some of our industry partners who will be presenting during this session. We've got Professor Tony Davies from Thermetrics, Hugh Parry from Steam Bio. We've also got a presentation from Spectrum Technologies. We've had some technical issues, which means they may not be able to join us, but let's see what happens during this session. Hopefully John Davies and John Mowat will still be able to join us. Otherwise, I'll do my best to present their session. I'm also joined today by my colleagues, Tom Johnson and Mike Walker. Tom Johnson will be speaking about our thin film coating facility at CPE, and also Mike Walker is supporting on the comments and Q&A for this session. So if you've got any questions, please pop them into the comments, the chat box, and we'll answer them at the end of the session during the Q&A. So rather than put them into the Q&A box itself, put it into the chat, because I think there's been some issues with that this morning. Without further ado then, if Georgia could just share my my presentation, please. So what I'd like to do today is following on from the theme of the Photonics cluster, following on from the theme of Photonics on the cluster stage today. We'll be explaining what CPE, the Centre for Photonics Expertise, is doing to support industry in Wales, and how what we're doing and how we're working with our industry partners to drive innovation using photonics technologies. So I'll be providing a bit of an introduction and background to CPE. Then Tom will be talking about our coating facilities, and then I'll hand over to our industry partners to tell you about the exciting projects they've been working on, and then we'll finish with the Q&A. So CPE is a Pan-Wales programme. It's funded by ERDF, the European Regional Development Fund, through the Welsh Government to support university industry collaboration. We consist of 4 university partners. Wrexham Glyndŵr University are the lead partner, who are based at the Optics Centre in St Asaph. There's a lovely picture of it here on the slide. We also have Aberystwyth University, Bangor University, and the University of South Wales. And we are funded to boost business growth in Wales, specifically West Wales and the Valleys, by supporting product and process development on projects that are specific to company needs. And you'll hear some great examples of projects later on in this session. So here's a little bit of a background about us. CPE was launched in 2019, and we've worked with over 42 companies on the improvement of 60 products or processes. These projects are very much company focused, and a key part of the projects is also about developing collaborative working relationships between industry and academia that then might lead on to longer term collaborations beyond CPE. So a number of grants have been applied for that total to the value of £2 million, and there's more coming on the horizon as well. And 3 of the projects have led to KES studentships, so funded PhD or master's studentships, as well as 2 net jobs being created in industry. So you can see the impact of the growth on businesses through CPE. Also, this value here, the £340,000, that refers to pledged in-kind investment in R&D. So this is the staff costs matched by our industrial collaborators. So every CP project requires matched in-kind contribution from company staff costs to the project. So there's no cash cost contribution to work with us. And just to give you an idea of the average value of the project, that's about £5,000 to £6,000 in staff costs. And finally, a major investment for CPEE was the installation of brand new £1.2 million thin film coating facility at the Optics Centre, and Tom will tell you a bit more later on. So first of all then, what is photonics? Photonics is a light-based technology. It involves the generation, detection, and manipulation of light. So the generation of light could be through lasers, LEDs, light bulbs, screens. The detection of light could be through cameras, sensors, and solar cells. And a good example of manipulation of light could be through the telecoms industry, where you get phone and internet signals through fiber optic cables. So photonics underpins our everyday lives. And to illustrate that, let's try and think about what life would be without photonics. So let's strip photonics out of our lives. And so here's a picture of a telephone. This is what you could use to contact your family, your friends. You might have this phone in your house that's plugged into the wall. Or maybe you're lucky enough to have a mobile phone where you can send text messages to your friends. On the second picture, we've got a screen. This is a cathode ray tube TV. Or you might have a similar looking monitor for your desktop PC, but it's pretty bulky and heavy. If we want to use the internet, then signals are sent down copper wire cables where your phone line comes in. It's a bit slow, but it works. And then finally, if you want to keep warm, then we have to burn fuel like coal or gas. And this is pretty much life, was pretty much what life was like back in the 90s. And by the following decade, the digital age really began to grow exponentially, as well as the range of photonics technologies available. So let's bring photonics technologies back into our lives now. Mobile phones have become more than just a phone for us. You know, the smartphone has given us high definition touchscreen device that can take photos and videos. It's got multiple cameras and sensors, and it's become something that, you know, we rely on every day, every minute of every day. Photonics technology is packed into these phones that are just can be put in our pockets. The screens that we're all watching on now are slim and lightweight compared with the old CRT technology, to the point where you can now have a screen that covers an entire building. Fibre broadband is available to 95% of the UK, giving us internet speeds that are 5 or 6 times faster than the ADSL that uses your telephone line. And then finally, for energy, about 40% of the UK's total electricity is produced from renewable energy sources, with 3 to 4% from solar photovoltaics. And the solar power industry is growing year on year. And this is an area relevant to the collaboration with Steam Bio, who you'll hear from later. Also, another of our industry partners, Graph Marine, will be presenting a showcase webinar later today at 3 o'clock on carbon reduction in the marine sector using photovoltaic cells. So the next big question is, you know, I've explained how photonics is woven into our lives today. So how is it relevant then to businesses? How is it relevant to industry? And so what I'd like to say is that our focus at CPE isn't just in the photonics industry. We do support photonics companies, but they actually make up less than 25% of the companies we work with. So our focus really is in using photonics technologies applied across all industries like the ones listed here, so manufacturing, life sciences, automotive, aerospace, and so on. And this would be through photonics solutions like sensing and measurement, vision systems, laser processing, spectroscopy, thin film coatings, and many of the solutions, photonic solutions, are now accessible and really low cost, thanks to the advanced technologies of the smartphone. So it's giving us low-cost sensors for example, object detection, environmental sensing, also cameras, for example, this 8 megapixel camera here from Raspberry Pi. 3D printers as well has come a long way. They use UV lasers to produce high resolution and high accuracy parts for prototype and production. You can also use lasers for cutting, engraving, and also, for example, printed circuit boards like this Raspberry Pi example, but also on laser wire marking, with spectrum technologies. And the final example here is near-infrared spectroscopy that can be used to sort between different types of plastic at a recycling plant. So we have 6 core areas of expertise at CPE based on years of established research and facilities at the 4 universities. So we've got laser processing, thin film coatings, optical design and prototyping. But rather than go into each one in detail, I want to instead put a slightly different context and explain how these are relevant to everyday applications. So our projects tend to fall into these 6 main categories. So with production line improvements, for example, we worked with a company called Welsh Slate. This image here you can see is a pallet of very tightly packed roofing slates. And it's a great example of an automated product counting system that was developed with Bangor University with a simple camera system. And they wrote the software as well to go with it to improve the accuracy compared with the previous sort of manually counting process. In the area of quality control, we're working with companies looking at how to improve quality control monitoring or manufactured parts using sensors or imaging systems, as well as inline monitoring systems to replace offline sample testing. In the area of prototype development, we're working with several companies developing new prototypes. So with Enviro365, we're using light-based sensors for environmental monitoring and thermetrics as well. Tony will be able to tell you more about the project that we're working on with their foot health monitoring device. Also in the area of prototype development, Diamond Centre Wales have worked with Bangor University on laser engraving micron-sized QR codes on diamonds. They're also using laser processing techniques with Transcend Packaging, looking at improvements to the paper straw manufacturing. On the area of product and process testing, we've been using spectroscopy techniques with Mon Naturals, looking at the particle size and chemical composition of a wound healing balm from Mon Naturals. Also with SureChill, we've looked at the thermal imaging techniques to look at the efficiency of off-grid refrigeration, which can be used not only for drinks, keeping drinks cool, but also vaccinations and blood as well. And then for modelling and analysis, we're working with a company called Tection on the analysis of their product for parasite egg detection in livestock, so sheep and cows. And we've improved the resolution of their imaging device by 3 times, which means that they can now move to a more AI-powered count where they can look at the speciation of the eggs. And we also do optical modelling using ray tracing like ZMAX, which we've used on a number of projects. So just to summarise then, CPE projects are about combining the company's knowledge of their business and their industry with our knowledge at CPE within photonics, of photonics-based solutions. And so this combined knowledge feeds into this hive of ideas. And the R&D projects, they formed, in the blue here, they form the basis of the collaboration. And you will be hearing the 3 case studies later on. And these 3 case studies, they feed into these growth drivers, so collaboration, innovation, new products and processes. And ultimately, the goal of these CP projects is to support business growth. And the growth outcomes could be in cost savings or improved yield. They also could be in developing new markets or feeding into grant applications beyond CPE, as well as new jobs as well. And so just going back then to our expertise at CPE, as well as having a team of academics with engineering backgrounds in various areas of photonics, we also have state-of-the-art facilities at CPE. We have laser processing labs, spectroscopy systems, prototype facilities, as well as our flagship facility, the thin film coatings facility. So here to tell you about that is my colleague Tom Johnson from Wrexham Glyndŵr University. Tom, over to you. Are you there, Tom?
I am here. Can you hear me? Can you see me?
Yes, there we go. Yes.
And you can hear me as well?
Yeah,
Can you hear
good.
me?
Yes, I can hear you, Tom.
Yeah, good. Okay. Okay, I'll start again. So my name's Tom. I head up the research team here at Wrexham Glyndŵr University for the CPE. Just a few minutes on my slides here, and that's just to explain to you what our facilities are and how they work. I've tried to keep it not too technical, but hopefully it should work for both those who understand photonics and those who don't. So we can move on to the next slide. I'll just move on in my notes as well. So at CPE at Wrexham Glyndŵr University, we've got three main areas that we look at with our equipment. That is optical analysis using the spectrophotometer, the thin film coatings using our coating plant, and environmental testing using our environmental chamber. The spectrophotometer is mainly concerned with the measurement of reflection and transmission properties of a material, normally glass, as a function of its wavelength. So basically all it's doing is looking at a piece of glass and understanding what light bounces off that and what light transfers through it. It's a bit more complicated than that, but that's the main part. The thin film coating plant, that's used for a wide range of applications, and that can be from anything from protecting from scratches or environmental exposure to building up things like semiconductors. And the environmental chamber, that is used mainly for humidity and temperature control, and to understand how a product works either in a different environment or to actually put it through some environmental stress screening to make sure that it can withstand up to a certain specification. So we move on to the next slide. I just want to explain really what an optical thin film coating is. So the purpose of any optical thin film coating is to modify the transmittance or reflectance properties of the substrate material that you've put the coating onto. There are many different types of coating that you can have. The one we're going to look at on the screen in a minute is anti-reflection, but there are also other ones, things like high reflection, which would be a mirror, partial reflection, which is known as a beam splitter, polarization, which means that only one type of polarized light is going through, a filter to stop certain parts of wavelengths heading through there, and you can also get a protection coating and conductive coatings as well. Let's move my note a second. So the optical coatings are constructed of thin layers, as you can see in our diagram here. We've got the substrate at the bottom in blue and then a thin coating on the top. Now, normally an incident ray of light would hit the substrate, bend a little and send a reflected ray back out, which we would see normally, for example, on your phone or an ATM machine as a reflection. This kind of coating, a single layer anti-reflection coating, what that does is, as you can see the incident light coming in, it reflects as we would normally get with a reflection on the glass. It's also refracted a little bit. The coating is then designed to be a specific distance apart, which means that when we hit the next boundary to go into our substrate, we get a second reflected ray, as well as a bit more refraction and the light going through. On the right-hand side of the diagram, you can see that because of the specific length, the two wavelengths are slightly out. And when these are added together, it amounts to no light coming through because the sum of amplitudes cancels each other out. So this is used basically to remove any reflection you get from the substrate. Now this only works on this one at a specific wavelength, but you can build up these layers and you can have many tens of layers on there, allowing you to do that at both a much wider wavelength and spectrum. If we move on to the next slide, you see a couple of different uses here for the thin film applications. So we know, most people will know it really from things like spectacles, where they will normally have an anti-reflection coating on, as well as a protection coating, something getting scratched so much. It's also quite noticeable as well on things like ATM screens. You can move all the way up to things like creating mirrors, and you'll find that in things like car headlights reflectors. And then if we go on to the next screen. Here this shows us our new, very expensive, very lovely, very clever coating machine. So as a side says, this is for R&D production of high density thin films. We use that for prototyping. And we don't do mass production, but we can help set up the processes to help you do mass production. It's a very large chamber, 1350 millimeters, and it's got 2 lovely electron beam deposition sources and 1 thermal evaporator. Oh, I'm sorry, I'm getting some beeping on my... Can anyone hear me? Apologies, I think my headphones have just died. Can someone just let me know that you can all still hear me?
All right.
I'm not sure if anybody can hear me now.
Go to Bluetooth.
Okay, I believe that you can all still hear me, so I will continue. Unfortunately, I can't hear anybody else if they need to get hold of me. So our the next part, okay, is the plasma ion-assisted deposition, which is an RF plasma source for dense, non-shifting films and low-temperature deposition. And then this is all controlled with the integrated optical monitoring system. If we move on to the next slide, sorry. Okay, so that's the spectrophotometer. As we said at the beginning, the spectrophotometer measures the transmission, reflection, and absorbance of optical coatings. So this is normally used in conjunction with the thin film coating plant, so we can measure the coatings that we've created. It can measure from UVC to infrared, so 175 nanometers to 3,300, and it can measure over a very wide range of angles from 0 to 80 degrees. And then last but not least, we've got our environmental chamber on the next slide. So as we said before, this is for controlling temperature and humidity testing. We could do from -70 to 150, and from relative humidity of 0 to 98%. This is, for anyone who's familiar with it, it's able to do nearly all of the ISO and MIL standard tests for defense, etc., that anyone could think of. And it's a lovely piece of kit, this one. And I think that pretty much sums me up. Apologies for the headphone problem.
And apologies for the technical difficulties there. It is a live event, so things like that are going to happen. Yeah, so thanks for that overview, Tom, of the optical thin film coating facility. I think it's a great example of the types of facilities that we have at CPPE that are available to companies. You know, they don't have to pay for any of the access to the equipment. It, as I said before, it is based on matched contribution in staff costs. So this is really a unique opportunity for businesses based in West Wales and the Valleys. If we can move on now to a presentation from thermetrics from Professor Tony Davies, if he is there. I'll hand over to you then, Tony, if that's all right. I think you're on mute.
Screen shares, yes. Everything working fine? Yes, you can hear me? Good. So, what do I want to go through this morning is basically a fairly early stage project with the CPE. I'm also Professor of Analytical Science at the University of South Wales, and during the lockdown period was introduced to thermetrics and some of their needs and desires in a device called the podium. The podium is a technology to try and help out patients with diabetic foot care issues It helps the healthcare professionals objectively assess the feet, and we've heard all the stories about all the problems during the COVID, that standard regular treatments are not happening. It's only everybody's having to work on emergency only. But the podium assesses the healthcare. It shares images across the clinical communities, which is very much aligned with the NHS's digital health initiatives. So images can be taken in the community by less skilled clinical support people, and then be assessed by the more professional, the higher trained specialisms, without them having to go out into the community themselves. So this is very much looking at trying to get better healthcare for people who cannot attend the hospitals in current times, and also for going forward, because this is the direction everything's moving. So what is the problem? Well, there's a massive problem with diabetes. Everybody's probably heard about this. It is an epidemic. It's an epidemic that's going to kill an awful lot more people than COVID will do in the next 5 to 10 years. 6.4% of all diabetes have a foot ulcer, and this is what is likely to lead to their deaths, because 34% of these need amputations. That's a leg every 30 seconds. 50% of the people who have these amputations will die within 5 years. And if you think back to some of the stories around cancer survival rates, this means that people with diabetes and developing diabetic foot ulcers have a worse survival chance than people with a lot of cancers. Okay, so what does that mean? In the UK, about 90,000 people have diabetic foot ulcers as we speak. In the US, 8 million. Okay, total spend, diabetic foot in the UK, about $1 billion. 11 billion in the US. Foot-related lower limb amputations, 8,500 at between 40 to 100k in total costs to us, who are funding the NHS in the UK per year. Okay, so this is the sort of numbers that we're looking at here. Not a great position to be in. So we move from diabetes, getting significantly worse development of the ulcers, because diabetes essentially stops you feeling your feet. You get what they call neuropathy. So you don't know when you're injuring it. Person without diabetes can walk around, knows when the shoe's catching a bit, itching a bit, knows when they're developing sort of problems, and tends to rest the foot themselves. People with diabetes with neuropathy don't realize they're doing that. So quite often you don't catch the fact you've got a problem until you actually start to develop the foot ulcers. This is not great. And people with neuropathy, and with diabetic feet, they tend to only have appointments every 12 months to get checked up. It's for way too long, so there needs to be a better way of dealing with this. So, as we've mentioned, 8,500 amputations of one sort or another in 2019. That's 1 year's figures. Okay, and if you look at the figures, that leads to around about 3,400 unnecessary deaths. Why is it unnecessary? So, what is £1 billion? What are we looking at now? So, there's a very good Dutch scientist who's been looking at this, Jaap van Netten. He looked at all of the different studies that were published globally and has come out with the figures that around 75% of all foot ulcers are actually preventable. The problem is the treatment intervals, the assessment intervals, and the fact that people don't know what is actually happening until it's too late. The ulcer has been developed. So what are we aiming the product at? What are we aiming the podium product at? So basically, let's try and pick up earlier signs of pathologies, of problems with the feet. And these do show up. They're there. They're there for people to pick up on and then drive a treatment pathway, even if it's just rest, that will stop them developing into foot ulcers, which they can then go septic and require operations and things like that. Okay, so what we developed within Thermetrics was a product which could assess the feet for developing pathologies, developing inflammations, and then could continue to monitor those inflammations as a route to actually getting better treatment. What's happened in the deployment of this technology is that we've gone within the healthcare professionals, and they're finding more uses of this. So when originally they were thinking of preventing foot ulcers, that's fine, but you've got people who at that point have not really been flagged in the healthcare system. Yes, they're diabetics, but they're not going for regular foot checks. Okay, what has been seen by the discussions with the healthcare professionals is there's a really good way of monitoring post-intervention. So you've picked something up, maybe you're treating it with cream. Are they working? So monitoring the feet as a part of the treatment pathway, and then discussions in what the NHS calls multidisciplinary teams. These are multidisciplinary support teams that are made up of specialisms plus GPs plus diabetic nurses, etc. They get around and discuss individual patients These standardized imaging will help in those discussions and get faster results to the patients that need it. And at the end of the day, looking at those statistics, we are going to be the patients. So what makes up the podium professional? Why is this of interest in the photonics environment? So what we see here is basically there's a device, this podium professional, that's the device that does the scanning. So that's where the imagery, liquid crystal sheets gets it. You take using a tablet, you get the measurements directly from there. They come across here. You get foot photographs made, and these are standardized foot photographs. And some of our clinicians have come back and said, you know, the fact you can generate a standardized photograph is a huge step forward for us, rather than different people taking photographs with a mobile phone. These are then uploaded to a central server, and it's a central server which allows people then to communicate in groups offline. Very important during the Metrics times, the fact that we can actually have almost like Zoom calls of people discussing patients, discussing the treatment pathways, identifying when the treatment pathways aren't working, and then making communal decisions on how to improve the pathway without having to have the patient turn up in a hospital environment. So that is what makes up the podium professional. How does this come about? This has come about initially by discussions with podiatrists, but the expanding use of these systems has meant there was a lot more input coming into what the device needs to do. So this comes back to the user requirements that were discussed with a CPE. The customer base has expanded into the NHS, private podiatry, care home settings, and other types of clinics. And as we move across this list, you'll see they actually have quite different requirements and quite different assessments of how the technology, this foot measurement technology, will work with them. Okay, so as we move it across, we've got a lot of different impacts coming in there, and the original designs were based on a limited case around the podiatrist, but the expanding business cases has meant that there is far more required of the device, and that at the end of the day, we're talking about a device that interacts with you as a patient. Therefore, all of the medical device rules and regulations also come in as a requirements basis. So what has happened is, since the company was originally founded, they developed this individual device. It works on nice photonics interaction, heat with liquid crystals, doing the sensing. Changes in temperature of the feet are reflected in a full-blown 2D scan of foot temperature, which is a much higher resolution than anything else on the market space. But the interaction and the actual use of having the device in the community has meant there's more requirements being added all the time to what it needs to do. So the company was lucky enough to get an HEFQ grant to work with the University of South Wales as part of a Knowledge Exchange Innovation Fund. So this is industrial support. And as part of that industrial support, because the company is based here in Abercynon, is to look at whether or not the centre, the CPE, the Centre for Photonics Expertise, can help out in some of the way the device is designed itself to meet some of these new requirements that we're having. So during the pandemic, everybody working from home, essentially, we looked at the requirements of the instrument, the current instrument that's on the market, against where it needs to be to meet the wider requirements that are coming in. A number of different versions of requirements for what we're calling Podium 2.0 was drawn up. There have already been patents filed around some of the photonics aspects of it, some of the different liquid crystal bounded sheets that are doing the temperature measurements, and a technical demonstrator design has been completed during lockdown. So that's really good. What's great is, since last month, we've now got access to the photonics laboratories at USW. We can actually start putting these instruments together, trying to build it up, trying to see what works and what doesn't. Components are there, and the ideas have gone forward to a CES2 MRes application, which has been approved within USW. I think the final paperwork is with Bangor for that. So that will be starting in October. So that's looking very good. So what are we looking for? We're looking for an initial alpha technical prototype. Now, because it's a medical device, we obviously can't put that in front of patients, but we can assess the technology against the requirements. And the requirements come from surveys of patients and clients and customer bases internationally, because these devices are also deployed into Australia, over in the Americas and places like that. So there's a lot of feedback coming back on what the device does well and where they'd like to see improvements. And the improvements are what feeds the CPE project. So CES2 MRes will hopefully commence in October. We'll get an alpha prototype available to be checked out. This will be reviewed by the board, and the board's made up of clinicians. We've got surgeons on the board. We've got podiatrists and things like that. The technical prototype will be assessed. This will go through and also be assessed about Class 1 or Class 2A medical device clarifications. This will then be presented to the commercial partners, and we will look to then take the CES2 MRes up to the next level and decide on whether we're going to go for an Innovate UK application, which will follow on from the MRes. So that's in a nutshell what the podium is, where the podium wants to be, and how CPE, through their skills with the photonics and the imagery and the image processing, can help us moving this product forward for a Welsh company. The devices are built in Wales. The components are built in Wales. It's a wonderful Welsh initiative that has led to the products at the moment. And hopefully CPE can help the company make another step forward. Thank you very much.
Overview. And just, yes, I mean, that's a fantastic example of types of photonics technologies applied to healthcare, and you can see that, you know, it could make a huge difference to diabetic patients. So very best of luck with Podium 2.0. So I'm just going to pass you over then to our next speaker, Hugh Parry from Steam Bio, for him to tell you about the projects that he's working on now.
Okay.
Oh, it's my turn to share my screen, isn't it?
I hope so.
Yes.
Far
I
away.
shall just do that.
No. Not this. Keep going.
Okay. Hang on.
That's fine.
Just a minute.
Right. While you're loading that up, I'll just give an overview of what I'm going to talk about. Here we are. Every little I like plagiarizing other people's ideas. Shows. I'd like to talk about support that CPE provided to me and the companies that I'm involved with in some grant applications. So every little helps refers to the support that CPE have provided. So if we could go to the first slide, I'll introduce myself. Network New Europe is an innovation consultancy where, building on my background, so over 25 years involvement, particularly in European grant funding, some UK funding, but much more engagement with European funding model, because quite frankly, it's larger money and it can actually have more impact, in my opinion. Whilst at Network New Europe, I wrote, and then as a participant, I led the exploitation of a project that was called Steam Bio. Steam Bio was branded by the European Commission evaluators as a lighthouse project, and that it was highly innovative in its outputs. As part of the exploitation work, I established Steam Bio Limited midway through as a vehicle to take the results of that project forward. Brought in other participants from that project with core knowledge and skill. Both of these businesses are registered in Colwyn Bay, North Wales. The purpose of Steam Bio is to produce innovative, clean burning solid biofuel, water and biochemicals from various woody biomass. Doesn't matter what the woody biomass is. In Steam Bio project, we're using stem wood, thinnings, cuttings from pine, from beech, olive prunings, vineyard prunings, and so forth. So as I said, we set up Steam Bio Limited as the vehicle to take the project results forward into commercialization. So next slide, please. We would then, during the delivery of the Steam Bio project, we were approached by people from Namibia at the European Biomass Conference and Exhibition, where I was hosting a stand. The problem is massive. Bush encroachment in Namibia alone covers 45 million hectares. That's twice the size of the Great British Island. It creates societal, environmental and economic damage. That sounds very twee, but actually going out there and you see into the horizon the bush encroachment. It takes away, degrades the savanna, so plants and productive, it ceases to be productive, and also the wild animals cannot roam, and because they're trapped with it. And that's an important economic aspect as well, because ecotourism right across southern Africa is a big growing sector, albeit it's somewhat restricted at the moment through the pandemic. The need for steam bio that was identified by the people in Namibia is it offered the potential to create value from the bush. By creating value from the bush, it then creates the incentive for people to clear the land. At the moment, there isn't an incentive to recover the land. It's too expensive. What's the return on investment? So therefore, this project creates an opportunity to generate value from the bush, a clean burning biofuel, and water, which is very, very important out there, and chemicals. You're in a region with water shortage and persistent drought, which is actually getting worse through climate change. To do this, to prove it, we need to validate it at a larger scale than we have done already. At the moment, we had a prototype system processing at 100 odd kilos an hour in southern Spain. We need to run the plant larger and for longer. We need to prove it technically, environmentally. We need to prove it with a market, both in industrial and domestic applications, and to prove that it's economically viable. We have partners in Southern Africa who are able to then take on the next stage and pull down commercial investment funding. But first, we need to validate. Next slide, please. Then we come to the need, and like everything, it comes down to where's the money. Or as Tom Cruise said, show me the money. Commercial funding for this step is risk averse. We've proved it at a level, but it's still highly risky to go to the next stage. I know, I've tried. Then we come to grant funding. Grant funding has been my bread and butter for the past 20 odd years. But it's getting increasingly competitive, and I'll show you some numbers later as to how competitive grant funding is getting. The applications need to be very, very strongly aligned to the call. You need to make sure everything is spot on. It needs to be a strongly evidenced rationale for what's being done. The business justification needs to be robust. The work plan needs to be fully costed. It needs to be really well written. And then, just as an extra thing, you need to be lucky. Doesn't matter how perfect the bid is, if you have an evaluator who doesn't like you, you have no hope. And I've had experienced that, trust me. Now, we want our process to be powered by renewables. Namibia has got some of the best solar resource in the world. One of the advantages of its location, and it doesn't rain very much. Bush encroachment is very widespread, but it's not always close to the grid. You're talking across Africa as a whole, 80% of fuel is local firewood. So biomass is a very big, abundant resource, but it needs to be made into a usable format. Next slide, please. Now, where does CPE come into the story? As I said, Namibia has got some fantastic resource. It's very low density population, very lovely country. It's a wonderful country to visit. I've only visited it once, but for a short period of time. Now, we looked at various UK and European funding opportunities, and in that process, we recognized and identified that we're looking at a renewable technology. It would be highly inappropriate to go anywhere apart from renewable power supply. Because of the abundant solar resource, we wanted to make sure we had the PV requirements fully ensured. Now, we contacted CPE. CPE did a full mapping of the PV availability across Namibia for us. They provided costed options. Now, one of the complications is that our process is a continuous process that likes to run 24/7. It doesn't want to switch off at night. So unfortunately at night, we can't get any PV. So we needed to include within that the options of how to store the power, battery or other renewables as part of the mix. We looked at various options, and the one funding opportunity that came through, which seemed very good for us, was the last call of Horizon 2020 of the EU Green New Deal. The call was announced in January 2021, and CPE provided costing for the specific size and scale of unit that we needed for this application. So CPE provided two studies for us, one, an initial one, saying to us, yes, it's an economically good idea. They then provided costing for this system that was scaled for this application, but with the recognition that going past this stage, that there's a resource that we can call on to help us in the commercial implementation stage. Next slide, please. So what was the outcome? As I said, grant funding is very, very competitive and getting more so. Throughout the whole EU Green New Deal call, I think there are about 13 funding areas. The specific application we targeted was accelerating the green transition and energy access partnership with Africa. In other words, green energy in Africa, for which there are 142 applications, and the ratio of that was they were only going to fund 4 projects, a maximum of 4 projects at total spend of 40 million euros. Our application was very well written. Without being arrogant, it was probably one of the best bids I've ever written. It was strong and it was very well evidenced. We had more evidence than we could put into the application. The CPA studies were a core part of this body of evidence. As I said, every little helps. We asked for 9.94 million euros in grant funding, of which SteamBio requested 950,000. We are in a leading role in this project. We are leading it. We are not the coordinator, thanks to Brexit, but also we needed a more established research centre from mainland Europe to act as the coordinator. The application scored 15 out of 15. It's a maximum. People who are aware of EU grant funding recognise that that's a pretty good score. I've never achieved that before. Next slide, please. So what's our plan? Where do we go from here? Yes, grant funding is a core part of it, but it's not all of it. We're currently in what's called grant preparation phase. Our target start date is the 1st of September. It's a 3-year project. It is a very detailed piece of work. The participants, 15 partners, are already actively discussing the work plan so that we start on the go. There's no messing with this project. There's no delay. People are getting ready already to start on the 1st of September. We will build within the first 12 months, design and build a unit which will be shipped out to central Namibia, the location identified and shared with CPE in the costing of the plant. It will process continually 250 kilos an hour of chipped bush, over 70 tons a month, to produce over 500 tons of solid clean burning fuel, which will recover 250 cubic meters of water and biochemicals. It will enable the restoration of 80 hectares of land degraded. Importantly, as part of this is the social and economic validation. It's no longer a case, does my technology work? It's a case of proving that there is market acceptance out there in Botswana, in South Africa, and in Namibia, and to prove that the business case works so that we can then go into the important next phase, pulling down and securing commercial investment. This is the last stage for us, this project, before we go into full-scale production. 30 units processing 10 tonnes an hour across southern Africa will generate income for us of over 150 million euro. And importantly, it will clear 6,000 square kilometres of encroached land, a massive area, which is quite daunting. It will make a big difference to millions of people's lives across southern Africa, which is quite impressive. That's what we intend to do. And as I said, CPE, they're provided an important part of the information that we needed to gather on our journey on this. Thank you. Next slide, please. So thank you, Giacomo. Any questions, please contact me. Thank you.
Thanks very much, Hugh. Wow, that's yeah, really exciting to listen to that. And I think it's a sort of a great example of how CPE can support, you know, in any way. This was like you said, it was a desk-based study utilising the photovoltaics expertise at Aberystwyth University, and just showing that how photonics as enabling technology can support companies like Hugh's. And yeah, I'm really excited to see what happens with this project, because it looks like the impact of it could be, you know, will be huge for people living in Southern Africa. Right, so on to the final presentation then. We have had technical difficulties, as I mentioned before. So unfortunately, you have me presenting the slides for Spectrum Technologies. So if you could just share, thank you, Georgia. So I'll try not to speak too long, because I just want to leave time for Q&A as well. But yes, thank you very much to John Mowat and John Davies from Spectrum Technologies for preparing these slides for today. As I said, I will do my best to talk through them. Spectrum Technologies worked with Bangor University on a CPPE project looking at laser marking of medical instruments. So just to give you a company overview then, Spectrum Technologies, they are a world leader in the design and manufacture of laser systems for laser wire processing. And these products can be found in across the aerospace, defence and medical devices industry, among others. It was originally formed in 1989 as part of BAE Systems, and the company developed a UV laser wire marking technology specifically for the aerospace industry, and has since become a global has become the global industry standard. So they supply virtually every major aircraft manufacturing facility around the world. So I think if you've been on a plane, then it will have wires that have been marked by Spectrum Technologies lasers. So yes, they've been used widely throughout the photonics sector for processing high performance electrical wires, used also in the production of mobile phones, laptops, and also medical devices and aerospace products. And recently the company has developed new technology for processing the wires using electrical motors and hybrid and electric drive vehicles. So the company, they design and manufacture industrial laser systems. The key products are a Capri UV laser wire and cable marking system for the aerospace industry, and also laser wire stripping for using UV and infrared laser systems for the electronics, aerospace and medical sectors. They have 50 employees in the UK, USA, Mexico, India and China. In the UK, they're in Wales. They are based in Bridgend. I have visited their factory. It's an impressive factory they've got there. So if you ever get a chance to work with Spectrum Technologies, it's great to see. So company goals and vision. let me see. Our goal is to be an innovating world-leading technology company developing and providing laser technology solutions to problems in wire and cable processing and manufacturing. They also are very active in research and development, I think, which is why, you know, they are a global leader in the markets that they serve. So here's just an overview of the markets they serve. So the laser wire marking equipment takes up 70% of their sales, predominantly in the aerospace industry, with 30% in the laser wire stripping equipment in the electronics sector. They also do equipment and service sales, which makes up 80-20 sort of ratio split. And as I said before, they are a global market leader. They export 95% of their sales to 60 plus countries across 6 continents. Wow, more than 1,000 wire markers installed, and much more than 1,000 wire strippers installed as well. Sorry, this is all new to me as I'm reading it, so it's very interesting for me as well. So the business challenge then. Spectrum's core business is in UV laser marking wires for the aerospace industry, next followed by infrared lasers for wire marking and stripping in the electronics, medical and automotive sector. And to grow the business, they need to identify potential markets outside the core business. So they've identified the medical market is an obvious sector to target, and already utilizes laser technology for some applications. So since 2016, all class 3 medical devices that require direct part marking must include a unique device identification code, UDI, and from 2020, all class 1, 2, and 3 devices require a UDI code. So the business challenge then was the UDI mark must have the following characteristics for a medical device. So I think this is an example here in the image. So it has to be a permanent mark with high contrast, and also sterilization resistant, so corrosion resistant. I think this is a key part, and it has to be unaffected by passivation or other surface treatment. So Spectrum Technologies first carried out this research around 2014 into how to produce a laser marking system for this application. And the research all pointed towards this 1 micron fiber laser. They carried out testing using high power infrared laser, but they failed the sterilization process, and there was corrosion. Also, they identified a UV laser as well, but again, they also failed the sterilization process. So the project was basically put on hold until contact with CPE in 2019. So let me see. So yeah, the project, as they say here, is it's based on in-kind contribution. So the company had to match their time. Then there were no additional costs required. And so for their particular project, they teamed up with Bangor University, who are experts in laser processing. They have a suite of lasers of different types to test on the Spectrum Technologies, to test on these medical devices. So the success, the outcome of the project was that Bangor identified the correct laser source and parameters to achieve all the criteria for UDI marking. So they've identified that the issue from the previous trials was that the pulse length was too long, and I'm guessing that Bangor University had identified other lasers then that were, yes, here we go, two solutions, less than 10 nanoseconds fiber lasers or ultra-fast systems did the job. So we've got a picture here before sterilization and after sterilization. So you can see here still a high contrast image there with the UDI mark. So future plans then, they are now in progress of developing a laser marking system, class 1, specifically for UDI marking of medical devices. They intend to use a short MOPA fiber laser rather than the ultra-fast systems, as the costs are significantly different. The MOPA laser is about 80% cheaper than ultra-fast lasers. So that's a huge driver. And current market research points to companies developing ultra-fast systems, so they intend to offer a much cheaper, cost-effective system to gain a foothold in the market. So, thanks for listening, and thank you again to John Mowat and John Davies. If you've got any questions for them, please pop them in the chat, because I believe they are on the session in the audience. Just to summarise, sorry, I do realise that we're running over slightly. That's just a quick slide about the qualifying criteria. I won't go into it. I'll just finalise now just by saying that if you do want to chat to us, to find out more, then myself and Carole will be happy to have a chat. We also have a booth, a virtual booth today, Tuesday and Wednesday. So pop along and say hi, and if we're not there, then just drop us an email. Do go along to the Graph Marine session today at 3 p.m, where Carole will be talking with Martin Lee. So I'll just stop my slides here just to see if we've got any questions to close the session. If we can invite all the speakers back as well, please. Thank you. There we go. Have we got any questions, Mike, to start off?
Thank you, Hazel. I'm not sure how much time we've got left, but we'll try and cover as much as we can now. We've got a quick question for Tony. It's been asked, without funding and support, would it have been possible for Photonics to still make and develop the product?
This is an advance of the existing product. So as it stands at the moment in the current financial climates and with COVID, the company would continue with the existing product with the issues that one has in the market space. So it is a way, with the funding that's available now, to actually move and address some of the issues, for example, that the NHS have been throwing up with the deployments and the various trusts, both in the northeast and the northwest and the southeast regional trusts that are using the instruments. So without that investment, there was no way that the company, as a startup with basically 7.5 people working in Abercynon, could have met the requirements there.
Thank you, Tony. Just very quickly for Hugh at Steam Bio as well.
Yeah.
About the conference, would the connection with Namibia have been as easy as you managed it?
No, it was identified. It was in Stockholm, and it was very useful. And it was, I'd never thought of anything about that. And as a result of that, I was actually asked to go out there and give a presentation, which was quite bizarre because it was to an empty room, but it's blasted out on speakers through this agricultural biomass show. So fascinating experience. Could I just go back to the previous thing about the CPE support, though, if I may? I invested my time, 3 or 4 months of my time at my cost, which is quite a lot, on the Steam Bio application, and therefore the work that CPE provided on the study as an important building blocks was not something I could have afforded with my resource. So it was useful and valuable.
Thank you, Hugh. Great answer there.
Thanks very much, everybody. And I think we'll have to close it there. As I said before, we do have a booth today. So I will close the session today. Thank you to all the speakers and for the audience for tuning in today, and enjoy the rest of Wales Tech Week. Goodbye, everyone.
Thank you for watching. Rewatch all of our sessions online. Thank you to our partners.